So this is example 3 on page 15 in the Exponents and Radicals workbook, and I'm going to do this example here. It's asking us to find the power of a product with rational exponents, write each expression as a power with a single positive exponent, then evaluate where possible. Okay, so the first A here is x to the power of 3 over 2, and that is in turn to the power of a half. Okay, so step number 1 is going to be to apply the power of a power law, taking the outside exponent and multiplying it by the inside exponent. Okay, so if we rewrite this, we're going to end up with x to the power of 3 over 2 times a half. And this is the same thing as, let's write it down here maybe. This is going to be x to the power of, so when you're multiplying fractions, you multiply upstairs by upstairs, downstairs by downstairs. So 3 times 1 is 3, 2 times 2 is 4. And that's it. They're asking us to express each as a power with a single positive exponent. So this exponent is positive, and we cannot evaluate this any further. So that's going to be our answer for A. Okay, let's have a look at B. In B, we have 16 times y to the power of a half, and then that's to the power of 3/4. So again, this is going to be, we have an outside exponent that we have to apply to the inside power. We have 16 here as a coefficient, so the 3/4 is going to be applied to the 16 as well as to the y to the power of a half. It's the power of a product law we're using here. So we're going to end up with 16 to the power of 3/4 times y to the power of a half times 3/4. Okay, now what we're going to do here is we're going to multiply these exponents out as, let's break it up into those 2 steps. We're going to get 16 to the power of 3/4 times y to the power of 3/4. 3/8 actually. 2 times 4 is 8. Okay. Now here we can't really evaluate the y to the power of 3/8. That's going to stay the same. Now 16 to the power of 3/4 can be evaluated, so we're going to do that on our calculator. So it's going to be 16 to the power, and then we just write it as a division. The exponent becomes a division, 3 divided by 4, like that, and that's going to be 8. So we're left with 8 times y to the power of 3/8, and that's our answer in B. In C, we have 64 times y to the power of a -half, and then that becomes the base, and we have an outside exponent of 2/3. Same thing, we're going to apply the outside exponent to 64 and to the y to the power of a half. So we're going to get 64 to the power of 2/3 times y to the power of -half. I'm going to put this in brackets because it's negative. times 2/3. 64 to the power of 2/3, we can evaluate that on the calculator. 64 to the power of 2/3 is 16. And then it's going to be y. And now what I'm going to do is I'm going to treat the negative sign has to be in there. So it's going to be negative, a negative fraction times a positive fraction. That's going to be a negative answer. 1 times 2 is 2. And then 2 times 3 is 6. Now we're not done yet, because this exponent, first of all, it's negative. They want the exponent to be positive. And second of all, this exponent 2 over 6 can be reduced. That fraction can be reduced. This can be reduced to negative 1/3. We're dividing numerator and denominator by 2. So we're left with 16 times y to the power of 1/3. And then finally, we're going to apply the negative exponent law to get rid of the negative sign in the exponent. So remember how that works. We drop the negative sign of the exponent and move the remaining power into the, in this case, into the denominator, across the division line. The 16 is a coefficient. It stays where it is, which means it's going to be in the numerator. So we're left with 16 over y to the power of 1/3. And that's our answer. And then finally, we have question D. Here we have 25 times x to the power of 6 times x to the power of negative 3 over 2, closing bracket, to the power of 1/2. We start by distributing this outside exponent into the bracket to the 25, to the x to the power of 6, and to the x to the power of negative 3 over 2. So this is going to give us 25 to the power of 1/2 times x to the power of 6 times 1/2 times x. I had to double check. There's actually 2 x's here. That's correct. Times x to the power of negative 3 over 2 times 1/2. 25 to the power of 1/2 is 5. Okay, and then we have x. So this 6 here, 6 times 1/2, 6 is in the numerator. So 6 times 1 is 6, divided by 2 is 3. And then we have another x. And so again, it's going to be a negative exponent because it's a negative times positive, so negative. 3 times 1 is 3, divided by 4. So negative 3/4. Okay, next step here is going to be, we can actually do, there are 2 things we can do. We can either apply the product law. So we're multiplying 2 powers with the same base. We would have to add those exponents. Or we can move this power into the, apply the negative exponent law and move this power into the denominator to get rid of the negative sign, and then apply the quotient law. But what I'm going to do here is I'm going to apply the product law, which means I'm going to add those exponents. So it's going to be 5 times x to the power of 3 plus negative 3/4. I'm going to continue up here. Now, if we take a look at the exponent here, we're adding, or actually it's going to become subtraction because plus and minus is minus. So we're going to be subtracting those exponents. Remember, when you're subtracting numbers that involve fractions, you need to have a common denominator. So I'm just going to deal with the subtraction here. So the 3 here can be written as 3 over 1 minus 3 over 4 And then we have to multiply this by 4, so we have the same denominator, and then we have to multiply upstairs by 4 as well, which will give us 3 times 4 is 12 over 4 minus 3 over 4. This is 9 over 4. So now we can rewrite what we have left. We have 5 times x to the power of 9 over 4. And that's it. That's our final answer.